Hello grade 9 students. Welcome to another virtual class. I am Miss Madhu Vadke. We have started with chapter 8 Quadrilaterals. In yesterday's class we revisited basic concepts of a quadrilateral. We learnt about the angle sum property of a quadrilateral and we learnt about 6 different types of quadrilaterals and also saw how they are related to each other. We also listed properties related to the sides, angles and diagonals for each of these quadrilaterals. I hope you all have memorized these properties. In today's video class, we will learn about the properties of a parallelogram. Look at these two figures. The first figure is a rectangle ABCD and the second figure is a parallelogram ABCD. Notice that AD is 5 centimeters in both the figures and AB is 3 centimeters in both the figures. So these two quadrilaterals will have same perimeter. However, the area of rectangle ABCD will be 5 into 3, that is length into breadth. Whereas the area of this parallelogram is given by base into the corresponding height. Here base is AB and the corresponding height is DP. Now DP will definitely be smaller than AD because in this right triangle ADB, AD is the hypotenuse which has to be the longest side. Since DB is smaller, this product AB into DP will be smaller than the product AB into AD, which is the area of rectangle. So we can see that the area of rectangle is greater than the area of parallelogram even though they have same perimeter. And this is the reason why sweet shops cut the sweets in the form of a parallelogram, so that each sweet takes up smaller area and they are able to cut more number of pieces. This is an example where you can relate knowledge of quadrilaterals with real life. So now we will start with the properties of parallelogram. In this chapter there are 8 theorems stating the properties of parallelograms and we need to prove these theorems. Theorem 8.1. A diagonal of a parallelogram divides it into 2 congruent triangles. So in this theorem we are given a parallelogram ABCD and what do we have to prove? That a diagonal divides it into 2 congruent triangles. Let's draw the diagonal DB. We have to show that triangle ADB is congruent to triangle CBD. Since ABCD is a parallelogram, opposite sides are going to be parallel. So we can write AB is parallel to DC. So if we take DB as the transversal, then angle CDB will be equal to angle DBA because they are alternate interior angles. Similarly, we will use the other pair of opposite sides, AD parallel to CB. So angle ADB will be equal to angle DBC. As they form alternate interior angles. In both cases, the transversal is DB. Let's mark this step as 1, this as 2, and we can say that DB is a common side in both the triangles. So from 1, 2 and 3 we can say that triangle ADB is congruent to triangle CBD. By which rule? In both triangles we have shown two corresponding angles and an included side equal. So the congruence criteria used here is angle, side, angle. So a diagonal of a parallelogram divides it into two congruent triangles. Theorem 8.2. In a parallelogram, opposite sides are equal. This is a pretty basic property of a parallelogram. However, it is easy to prove this property. In the previous theorem, we have shown that a diagonal divides a parallelogram into two congruent triangles. So once we prove these two triangles congruent, we can say that parts of these congruent triangles are also equal, and hence we can show the opposite sides equal. So the proof for this theorem will be exactly same that we did earlier. However, we will have to change this part, what we have to show. We are given a parallelogram and we have to show the opposite sides are equal. So we have to show that AB is equal to DC and AD is equal to BC. So we proceed in the same manner and show these two triangles congruent by ASA, and if the triangles are congruent, their parts are also congruent. So we can say that AB is equal to DC and AD is equal to BC, as they are corresponding parts of the congruent triangles that we have shown over here. Theorem 8.3. If each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. This theorem is exactly converse of theorem 8.2. So now we are given a quadrilateral. I'm drawing it like a parallelogram. However, what we are given in the question is that this is just a quadrilateral in which the opposite sides are equal. So in this quadrilateral ABCD, AB is given equal to DC and AD is equal to CB. We have to prove that this quadrilateral is a parallelogram. So we have to prove ABCD is a parallelogram. Let's draw one of the diagonals, AC. Now this theorem is easy to prove. We just have to show these two triangles congruent. DC equal to AB already given, AD equal to CB already given, and AC is a common side to both these triangles. So these two triangles will be congruent by SSS criteria. So triangle ADC is congruent to triangle CBA by side criteria. So if the triangles are congruent, then the corresponding angles are also equal. So we can say that angle 1 is equal to angle 2. Similarly, angle 3 will be equal to angle 4. What is the reason? They are corresponding parts of congruent triangles. Now if angle 1 is equal to 2, they form alternate interior angles with lines DC and AB cut by transversal AC. So we can say that AB is parallel to DC. Similarly, angle 3 and angle 4 form alternate interior angles with lines AD and CB, cut by transversal AC. So this implies that AD will be parallel to CB. Let's mark these results as 1 and 2. So what have we shown? In this quadrilateral, the opposite sides are parallel. So from 1 and 2, we can say ABCD is a parallelogram. Next theorem is 8.4. In a parallelogram, opposite angles are equal. To prove this theorem, we will use theorem 8.1, which says that the diagonal of a parallelogram divides it into two congruent triangles. So let's draw a figure and write down what is given. So this is parallelogram ABCD, which is given to us. We have to prove the opposite angles are equal. That means we have to prove angle A equal to angle C and angle D equal to angle B. Since we are using the first theorem, that is 8.1, we need to draw a diagonal. So let's draw diagonal AC. Triangle ADC will be congruent to triangle CBA. Reason: a diagonal divides parallelogram into two congruent triangles. So if the triangles are congruent, then their corresponding angles are equal. So angle D will be equal to angle, this is by CPCT. Likewise, to prove the other pair of opposite angles equal, we will have to draw the other diagonal. So we join point D to B. So we use the same theorem 8.1 to say that triangle ADB is congruent to triangle CBD. The same reason over here. So if the triangles are congruent, then their corresponding angles are equal. So we can say angle A is equal to angle C by CPCT. And hence we have shown that the opposite angles in a parallelogram are equal. Now theorem 8.5 is exactly converse of this theorem, which says that if in a quadrilateral each pair of opposite angles is equal, then it is a parallelogram. So let's consider a quadrilateral ABCD. What are we given in this theorem? Each pair of opposite angles is equal. So we are given angle A is equal to angle C and angle D is equal to angle B. We have to show that it is a parallelogram. To show ABCD a parallelogram, we will have to show opposite sides equal or parallel. But we will have to proceed according to the given data. So angle A is equal to angle C. Since they are equal, let's mark these two angles with some variable x. Likewise, we will mark angle D and B as y because both of them are equal. We know that the angle sum property of a quadrilateral is 360 degrees. So angle A plus angle B plus angle C plus angle D is 360 degrees. But angle A is x, angle B is y, angle C is x and angle D is y. So on adding we get 2 times x plus y equal to 360 degrees. So x plus y is equal to 180 degrees. But from the figure we can replace angle y as D and angle x as A. So we get angle D plus angle A equal to 180 degrees. These angles are made on the same side of this line DA and between the lines DC and AB. This means that angle D and A form co-interior angles. Between AB and CD cut by transversal AD. So this implies that AB is parallel to CD. Similarly, angle X in the figure is angle A and Y is angle B. So if we replace X plus Y with angle A plus angle B, we get sum of these two angles equal to 180 degrees. But these two angles are on the same side of line AB between the lines AD and CB. So they form co-interior angles where AB is the transversal. So we can say that AD is parallel to CB. Since we have proved opposite sides of this quadrilateral parallel, ABCD is a parallelogram. Theorem 8.6. The diagonals of a parallelogram bisect each other. So we are given a parallelogram ABCD. AC and DB are the diagonals that intersect at point O. We are given that ABCD is a parallelogram. What do we have to prove? The diagonals bisect each other. That means we have to show that AO is equal to OC and BO is equal to OD. To show these sides equal, we are going to prove the triangles containing them congruent. And these triangles are triangle AOB and triangle COD. Or we can prove triangle AOD congruent to triangle COB. Both ways we will get the same result. So in triangle AOB and triangle COD, since ABCD is a parallelogram, we can say that opposite sides are equal. And can we say that angle 1 is equal to 2? Yes, because we know that the opposite sides in a parallelogram are parallel, and hence angle 1 and angle 2 form alternate interior angles that are made by transversal AC with parallel lines AB and DC. So our next step will be angle 1 equal to 2 as they form alternate interior angles. Similarly, we can mark one more pair of alternate interior angles, angle 3 and angle 4, which are made by the same parallel lines, but the transversal is now BD. So angle 3 equal to angle 4, alternate interior angles made by AB parallel to DC, cut by transversal BD. From 1, 2 and 3 we have two corresponding angles and an included side of one triangle equal to two corresponding angles and one included side of the other triangle. So these two triangles are congruent by angle side angle. Therefore triangle AOB is congruent to triangle COD by ASA. And if the triangles are congruent, then their corresponding sides are also equal. So this implies AO is equal to CO and OB is equal to OD. Reason: congruent parts of congruent triangles. And hence we have shown that the diagonals of a parallelogram bisect each other. Theorem 8.7. If the diagonals of a quadrilateral bisect each other, then it is a parallelogram. This is exactly converse of theorem 8.6. Here we have a parallelogram and we had to prove that its diagonals bisect each other. In theorem 8.7, we have a quadrilateral in which the diagonals bisect each other and we have to show that it is a parallelogram. So let's consider a quadrilateral ABCD in which the diagonals are bisecting each other. So we are given that DO is equal to OB and AO is equal to OC. What do we have to prove? That this quadrilateral is a parallelogram. We will proceed in the same manner by proving two triangles congruent, that is triangle DOA and BOC. In these two triangles, angle DOA and angle COB are equal. Why? Because they are vertically opposite angles. And we are already given DO equal to OB and AO equal to OC. So in these two triangles, we have shown two corresponding sides equal and the angle included between them also equal. So these two triangles are congruent by SAS. So triangle DOA is congruent to triangle BOC by SAS. And when the triangles are congruent, their corresponding angles are equal. So we can say angle 1 is equal to angle 2. They are corresponding parts of congruent triangles. But if angle 1 is equal to angle 2, they form alternate interior angles which are made by transversal DB with lines DA and BC. So this implies AD is parallel to BC. Likewise, we can show triangle DOC congruent to triangle BOA and proceed in the same manner and show AB parallel to DC. The steps are going to be exactly same. So this will be part of your assignment. Theorem 8.8 is the last theorem based on the properties of a parallelogram. A quadrilateral is a parallelogram if a pair of opposite sides is equal and parallel. This is also another condition for a quadrilateral to be a parallelogram, which we are going to use in the exercise. So what are we given in the question? We are given a quadrilateral in which the opposite sides is equal and parallel. Let's consider a quadrilateral ABCD. In this quadrilateral, we are given a pair of opposite sides equal and parallel. So let's say AB is equal to DC and AB is also parallel to DC. We have to show that this quadrilateral is a parallelogram. In order to show ABCD is a parallelogram, we will have to divide it into two triangles. So let's draw a diagonal and show these two triangles congruent. So consider triangle ADC and triangle CBA. In these two triangles, we have one pair of corresponding sides equal, which is DC equal to AB. This is given Also, since DC is parallel to AB, if we consider AC as the transversal, then angle DCA will be equal to angle CAB. Let's mark these two angles as 1 and 2. So we have angle 1 equal to 2 as they are alternate interior angles made by DC parallel to AB, which is given in the question, cut by transversal AC. And AC is a common side in both these triangles. So now we can write triangle ADC congruent to triangle CBA. And what is the criteria? We have two sides and an included angle of one triangle equal to the corresponding two sides and an included angle of the other triangle. So these two triangles are congruent by SAS. And if these two triangles are congruent, then their corresponding angles are equal. So we can mark angle BCA equal to angle DAC. Let's mark these angles as 3 and 4. So we can write angle 4 is equal to angle 3. Now look at the figure. Angle 4 and angle 3 are alternate interior angles that are formed by lines AD and CB cut by transversal AC. So this implies that AD is parallel to BC. So now we have AB parallel to DC and AD parallel to BC. So from 1 and 2 we can say that ABCD is a parallelogram as both pairs of opposite sides are parallel. With this we come to the end of this video lesson. Your assignment for today is to write down the theorems and their proofs that we have done in today's video lesson in your notebook neatly. And memorize these properties of parallelogram. See you in the next class. Until then, goodbye.